All right, guys. So just going to go over a couple more examples here of predicting, because that's what we're going to be working on for most of the day today. About the last 20 minutes or so of class today, I'm going to hand out the lab sheet that for the lab that we're doing tomorrow, quickly outline what we're going to be doing, okay, and what you need to have done for tomorrow, okay, in terms of like basically just an observations chart is all you're going to need, and we'll talk about what that should look like, have that ready to go for tomorrow. The other thing here is that you will also have a quiz tomorrow, okay? And that quiz is going to be on prediction, and I will tweet that near the end of the day today, okay? So, quick review here. What is the first step to predicting the products of a reaction regardless of what reaction type it is? What is the first step in predicting the products of a reaction regardless of what type? Nope. What's that? Okay, write it out. Yes. Yes, write out the reactants. Then identify the type. Identifying the type is the most important step. Okay? You have to know what type of reaction is going on in order to figure out what is going to be produced as a result of what you have. So you write out your reactants, and then you figure out what kind of reaction is going on. If you have two ionic compounds, like in number 1, you have what kind of a reaction? Double replacement. So in a double replacement reaction, what do? Bill? Switch the metals. All right, so that means sodium is now with oxygen and calcium is now with chlorine. Because these are both ionic compounds, what do I have to do with them? Yeah, Nick. Right? So, no, Na was with Cl before. So I've already switched, but now what do I need to do with these? Drop and swap. Okay, that's my next thing. So oxygen is a -2, sodium is a +1, so this is Na2O. Okay, this is a +2, this is a -1, so we're looking at CaCl2. Now we go back and do what? Balance. Now we balance the reaction. There's 2 chlorines over here, but there's only 1 here, so I put a 2 there. That gives me 2 sodiums. There's 2 sodiums there. Everything else is a 1. Okay, so we're good. Is that ringing a bell? All right. Yeah, no. I would say get in the habit of writing the ones, just in case, like on a test, if I give you, here's just some balancing questions and they're fill in the blank. If they're fill in the blank and it's already balanced and you don't fill in anything, what do I assume? Right, I assume you didn't know how to do it and left it blank. Okay, so I would say just get in the habit of writing ones in there. It's not right or wrong. Okay, in that case, this way I'm sure. All right. All right, give you guys a minute. Try number 2. Actually, try 2 and 3. All right, so let's have a look here at number 2. So in number 2, I've got iron 3 bromide reacting with sulfur. So an ionic compound reacting with an element. Reaction is single replacement. Right, so in a single replacement reaction, we have to look at the thing that's by itself. In this case, it's sulfur, and sulfur is a non-metal. That means sulfur will be replacing the non-metal in the ionic compound. So bromine's going to be out on its own, and sulfur will end up with iron. Okay, so we'll have FeS, and we'll have bromine. Now, over here, iron was a +3 charge. How did I know that? Well, because bromine is -1, and there were 3 of them. That means that iron had to be a +3. So is iron still a +3 on the product side? Yes, it is. Okay, that doesn't change. Being in a reaction doesn't change what kind of iron you started with. All right, so it's still a +3. So when I do my swap and drop, I've got +3, -2. So this is Fe2S3 for my compound. All right, bromine, is it special? Yes, so it comes as a 2. All right, now that I've done that, and single replacement guys are the ones where you have really the most things to check on the product side, because you're going to have an ionic compound that you have to swap and drop, and you're getting something by itself. Oftentimes, it'll be a special element that requires a number with it. Okay, now to balance here, we always start with the thing present in the highest number. That's sulfur, 8. On this side, 3. What's the lowest common multiple of 8 and 3? 24. is the lowest common multiple of 8 and 3. 8 times 3 is 24. All right, there's no other number they both divide into. All right, so what we have to do then is put a 3 here and an 8 here. All right, that balances my sulfur, but that gives me how many iron? 16. So I need a 16 over here. These are big numbers. All right, and I've got 16 times 3 bromines is 48. Okay, what times 2 is 48? 24. All right, so lots of big numbers in that one, and that is as low as it goes. Okay, I can't. 3 is my smallest number. I can't divide 8 or 16 by 3. All right, so they have to stay the way they are. Everybody with me on that one? Okay, what kind of reaction is number 3? It's a combustion reaction. How many times have we done this exact reaction now? This will be our 4th time. Okay, this will be our 4th time doing this exact same reaction with octane, the active ingredient in gasoline. Okay, products of a combustion reaction are always the same. Carbon dioxide and water. The only thing that changes is how much of each we're going to get. Now, the rules for balancing. Balance in alphabetical order and the rule of 2. Does the rule of 2 apply to this one? Yes, it does, because 8 is an even number. All right, 2 times 8 is 16. 2 times 18 is 36. 18 times 2 is 36. 16 times 2 is 32, and 18 more is 50. 25 times 2 is 50. All right. Questions on that one? All right. Try 4 and 5. All right, let's have a look at 4 and 5 here. So on number 4, I have 2 elements reacting with each other. That's a synthesis reaction, right? So that means I have to make a compound out of them. Now, I should always make sure if I'm making an ionic compound that I write what first? Metal or non-metal? Metal. Okay, always make sure the metal comes first. Okay, so we got Be with F, all right, and beryllium is a +2, okay, F is a -1, so we got swapped and dropped BeF2, and we're done because that's already balanced. Okay, we had 1 Be and 1 F, or 2 Fs on the other side. All right, for number 5, I've got chromium 3 nitride here, and it's all by itself. So what kind of reaction is that? Decomposition. So that's going to break down into chromium and nitrogen. Chromium's a metal. There are no special metals, okay, other than hydrogen. All right, and nitrogen is a non-metal. Is it a special non-metal? Yes, comes as a 2 when it's by itself. Now we got to go back and balance. 2 and 2 and 1. Okay, ought to do it. Okay. All right, try 6 and 7. Give you a couple minutes on those. All right, let's have a look at number 6 here. So in number 6, are these all ionic compounds? Yes, they are. If they have a polyatomic ion in them, they're an ionic compound, right? Metal, non-metal, metal, non-metal. All right, so we swap the metals here, and we end up that barium ends up with sulfate, and copper ends up with phosphate. Okay, so now we got to swap and drop. Barium is a +2 charge. Okay, sulfate is a -2, so that one's already good the way it is. All right, copper, I have to check because copper has more than one possible charge. It can be a 1 or a 2. Since there's only one sulfate here, and sulfates are -2, copper has to be +2. All right, so we got +2 here, and this is -3 over here. So we got Cu3, and then brackets PO4, 2. Okay. Now we got to balance everything. Okay, we've got 3 barium over here, but only 1 here, so we should probably put a 3 there. That gives us 3 sulfates, so we should put a 3 here. That makes our copper work. Everything else is a 1. Okay. That would probably be about as difficult as a double replacement reaction would get because of a multivalent metal and polyatomic ions. Okay, that's about as tough as they would get. All right, number 7 only starts with a compound, so it's what kind of reaction? Decomposition, right? So we're breaking down into lithium And nitrogen special, lithium is not. Okay, now we got a balance. I can put a 3 here, but if I do that, I'm just going to have to change it, aren't I? Okay, I've got to look at the nitrogen. There's 2 on this side. Now there are 2 on this side. That gives me 6 lithium. All right, try the last 4. I'll give you a couple more minutes on those, and then we'll go through them together. All right, let's have a look at the last 4 here. Okay, so for number 8, I've got carbon and hydrogen reacting with oxygen. What kind of reaction? Combustion, right? Okay, so we know the products are always CO2 and water. We're balanced alphabetically. Rule of 2 does not apply because 9 is an odd number, right? So 9 carbons, 20 hydrogens, 10 times 2 is 20. 9 times 2 oxygens is 18, plus 10 more is 28. 14 times 2 is 28. Okay? So the combustion ones really should be some of the easiest ones. You don't have to think at all about what the products are, okay? And you have rules for balancing. All right, number 9, I've got 2 elements reacting with each other, so that is a synthesis reaction, right? Okay, so nickel and phosphorus go together. All right, nickel is a multivalent metal. How do I tell what its charge is? Right, I go with the first one. In this case, I have to go with the first one because there's no way for me to figure out from a compound what the charge was on nickel. So I go with the first one because that's the most common. So what's the first charge listed for nickel? 2. All right, so we've got nickel being plus 2. Phosphorus, okay, is minus 3. So we got Ni3P2 as our formula there. Okay, now we start balancing. 4 is our highest number, so a 2 here gives me 4 phosphorus and 6 nickel. All right, number 10, zinc hydroxide reacting with potassium. What kind of reaction is that? Ionic compound reacts with an element is single replacement. Okay, this is a metal, so it's going to replace the metal in this compound. That means zinc ends up by itself and potassium ends up with hydroxide. Okay, zinc is not special. Potassium is a +1. This is a -1, so this is swapped and dropped correctly. Now all I have to do is make everything balance. I have 2 hydroxides on the reactant side. Now I have 2 on the product side. That gives me 2 potassium, so a 2 here will get everything balanced. All right. And then our last one, potassium permanganate reacts with calcium nitrate. What kind of reaction is this? Double replacement. They're both ionic compounds. So we switch partners for the metals. That means potassium ends up with nitrate. Calcium ends up with permanganate. All right. Nitrate's a -1. Potassium's a +1. So that compound is swapped and dropped. This is a +2. This is a -1. So we'll need brackets around that and a 2 outside of the brackets. Okay, again, probably about as hard as a double replacement reaction would get. Now we balance everything. So we got 2 nitrates on this side. Now we have 2 on that side. That gives me 2 potassium. So I go back over here and balance my potassium, which gives me 2 permanganates. There's 2 over here. So everything else is a 1. All right, making sense? Okay, we've still got a fair amount of time to get this practiced up. It's going to be important for us to be able to do this because tomorrow in the lab, you're going to have to predict the products of the reactions you are going to perform. Okay, so we need to make sure we know how to do this. Plus, you have a quiz tomorrow that's on exactly the same thing. All right, so you've got a bunch of worksheets there. Let's take those out, get to work on those, and I'd be happy to go over any ones you're having trouble with.